Next, let's dive down into implement solutions for apps. For this section of the exam, at a high level, you should know and understand the pros and cons and benefits of using one solution over another. Note also that in this version of the exam, neither Service Fabric nor batch services are covered, so you don't have to worry about those. In this review section, we'll drill down into a couple of these, but you'll have to do your homework to learn the rest. But I think this is a great decision tree to help guide answers on the exams. There's a link at the bottom, but great comparison of virtual machines versus app services, Azure Functions, Azure Kubernetes Service, and container instances. All of these are line items in this exam objective. So drilling down a little bit deeper, let's look at some of these. Microsoft Flow and Logic apps are both designer-first integration services that can create workflows. Both services integrate with the various SaaS and enterprise applications. Microsoft Flow, which is part of Office 365, is actually built on top of Logic apps. Functions and Logic apps are Azure services that enable serverless workloads. Azure Functions is a serverless compute service, whereas Azure Logic apps provides serverless workflows. Together, they can create complex orchestrations. An orchestration is a collection of functions or steps, which in Logic apps are called actions, and they are executed to accomplish a complex task. For example, to process a batch of orders, you might execute many instances of a function in parallel, wait for all instances to finish, and then execute a function that computes a result on the aggregate. For Azure Functions, you develop orchestrations by writing code and using the Durable Functions extension. For Logic apps, you create orchestrations by using a GUI or editing configuration files. Here are two scenarios for which web jobs may be the best choice, where you need more control over the code that listens for events, the job host object. Functions offer a limited number of ways to customize job host behavior in the host.json file, but sometimes you need to do things that can't be specified by a string in a JSON file. For example, only the WebJobs SDK lets you configure a custom retry policy for Azure storage. You have an Azure App Service app for which you want to run code sniglets and you want to manage them together in the same Azure DevOps environment. These are scenarios for which web jobs may be the best choice. Azure App Service, big thing to know and understand all the various aspects of this. The exams love this topic. Azure App Service is an HTTP-based service for hosting web applications, REST APIs, and mobile backends. You can develop in your favorite language, whether it's .NET, .NET Core, Java, Ruby, Node.js, PHP, or Python. Applications run and scale with ease on both Windows and Linux-based environments. App Service not only adds the power of Microsoft Azure to your application, such as security, load balancing, auto-scaling, and automated management. You can also take advantage of its DevOps capabilities, such as continuous deployment from Azure DevOps, GitHub, Docker Hub, and other sources, package management, staging environments, custom domain, and TLS/SSL certificates. In App Service, app settings are variables passed as environment variables to the application code. For Linux apps and custom containers, App Service passes app settings to the container using the --env flag to set the environment variable in the container. When you deploy your web app on Linux, mobile backend, or API app to Azure App Service, you can use a separate deployment slot instead of the default production slot when you're running in the standard, premium, or isolated app service plan tier. Make sure you know the differences between the plan tiers. Deployment slots are live apps with their own host names. App content and configuration elements can be swapped between two deployment slots, including the production slot. An Azure App Service plan provides the resources that an App Service app needs to run. Azure App Service scale units support many customers in each deployment. The free and shared SKU plans host customer workloads on multi-tenant workers. The basic and higher plans host customer workloads that are dedicated to only one app service plan. If you have a standard app service plan, all the apps in that plan will run in the same worker. If you scale out the worker, all the apps in that app service plan will be replicated on a new worker for each instance in your app service plan. By default, apps hosted in App Service are accessible directly through the internet and can reach only internet-hosted endpoints. But for many applications, you need to control the inbound and outbound network traffic. There are two main deployment types for Azure App Service. The multi-tenant public service hosts app service plans in the free, shared, basic, standard, premium, premium v2, and premium v3 pricing SKUs. The single-tenant app service environment, or ASE, host isolated SKU app service plans directly in your Azure virtual network. The features you use will depend on whether you're in the multi-tenant service or in an ASE. For the exam, make sure to review the inbound and outbound use cases for networking with app service. Just knowing the differences between each of the features will help to dissect such questions. Also, I'd recommend to really know and understand an ASE versus non-ASE environments. Containers are becoming the preferred way to package, deploy, and manage cloud applications. Azure Container Instances offers the fastest and simplest way to run a container in Azure without having to manage any virtual machines and without having to adapt a higher level service. In the example, the AZ Container Create command, as shown, specifies settings for a new virtual machine and subnet. Provide the name of a resource group that was created in a region where container group deployments in a virtual network are available. You can also deploy a container group to an existing virtual network by using a YAML file, a resource manager template, or another programmatic method such as with the Python SDK. You can also deploy from the Azure Container Registry. There are some considerations in managing running containers to be aware of for the exam. Configure liveness probes. Containerized applications may be run for extended periods of time, resulting in broken states that may need to be repaired by restarting the container. Azure Container Instances supports liveness probes so that you can configure your containers with your container group to restart if critical functionality is not working. Readiness probes. For containerized applications that serve traffic, you might want to verify your container is ready to handle incoming requests. Azure Container Instances supports readiness probes to include configurations so that your container can't be accessed under certain conditions. Start, stop. The restart policy setting of a container group determines how container instances start or stop by default. You can override the default setting by manually stopping or starting a container group. Note, if your container group is configured with an IP address, that IP address can change when the container group is restarted. You can use the AZ container command with start, stop, or restart. Update. To update an existing container group, issue the create command or use the Azure portal and specify the name of an existing group. Modify or add at least one property of the group that supports update when you redeploy. Certain properties don't support updates. Set other properties with the values you provided previously. If you don't set a value for a property, it refers to a default value. Here's a pro tip. A YAML file helps maintain a container group's deployment configuration and provides a starting point to deploy an updated group. If you use a different method to create the group, you can export the configuration to YAML by using AZ Container Export. To build and run applications successfully in Azure Kubernetes Service, or AKS, there are some key considerations to understand and implement. These areas include multi-tenancy and scheduler features, cluster and pod security, or business continuity and disaster recovery. If the resource needs of your applications change, you can manually scale an AKS cluster to run different number of nodes. When you scale down, nodes are carefully cordoned and drained to minimize disruption to running applications. When you scale up, AKS waits until the nodes are marked ready by the Kubernetes cluster before pods are scheduled on them. As part of the lifecycle on an AKS cluster, you often need to upgrade to the latest Kubernetes version. It's important that you apply the latest Kubernetes security releases or upgrade to get the latest features. This link provided will show you how to upgrade the master components or a single default node pool in AKS cluster. A proximity group is a logical grouping used to make sure Azure Compute resources are physically located close to each other. Some applications, like gaming, engineering simulations, and high-frequency trading, or HFT, require low latency and tasks that complete quickly. For high-performance computing, or HPC, scenarios such as these, consider using proximity placement groups, or PPG, for your cluster's node pools. Make sure to note the limitations on this link. To rapidly scale application workloads in an AKS cluster, you can use virtual nodes. With virtual nodes, you have quick provisioning of pods and only pay per second for the execution time. You don't need to wait for Kubernetes cluster autoscaler to deploy VM compute nodes to run the additional pods. Note that the virtual nodes are only supported with Linux pods and nodes. The virtual nodes add-on for AKS is based on the open source project Virtual Kubelet. There are many best practices to review here. You'll have to weigh your study time against the weight of this section. Remember that this section is only 10 to 15% of the exam.